Hello everyone, thanks for listening in. This is a short demonstration of DAOS, the Distributed Asynchronous Object Store with Intel's Optane DC persistent memory. Today we will show two applications running on our storage stack, so let's get to it. First, let's talk about our test environment. Our test cluster consists of a single I/O server with 6 Optane DC persistent memory DIMMs with 500 GB each, configured in interleaved mode, and 2 NVMe capable SSDs, each of 1.6 TB. The compute side consists of 4 compute nodes and are connected to the storage server with Intel OmniPath 100 adapters. The two applications that we will demonstrate today will be Plastic, which is a machine learning astronomy application that runs over Spark. Through this, we will demonstrate how we can access Spark objects through DAOS directly with the DAOS file system API, bypassing POSIX and all system calls, and we compare that to HDFS. The second application is plain old IOR to show the performance of our storage stack with small transfer sizes that highlights the low latency and high IOPS to obtain DC persistent memory and show how data is aggregated and transferred over to the NVMe SSD. The second use case will be with large transfer sizes to show how data is stored directly to the SSD and where the DAOS metadata will be kept in persistent memory. Our demo environment that you see here displays several metrics, including the performance we get with Spark over DAOS compared to Spark over HDFS, and all the IOR metrics that include bandwidth, IOPS, latency on the left-hand side. On the right-hand side, we show how the storage devices get utilized, and that consists of the Apache Pass or persistent memory devices that absorb all the small I/O requests, and the NVMe SSD capacity that absorb the large requests and the aggregated data from the Apache Pass tier, either when that tier is running short on space, or through an explicit request from the client side, which is what we will be doing in this demonstration. First, let's run this Plastic demo through the Jupyter notebook that we have here on the right-hand side. Plastic consists of two phases, the training phase and the prediction phase. In this demonstration, we already imported the training data into the DAOS tier through a fuse layer that copied the data over into a DAOS container, and we will show the prediction phase, in this case running, and show the performance that we get with both DAOS and HDFS. As you can see from the graph, the DAOS number was around 2 seconds, while the time it took to run the prediction phase over HDFS took around 30 seconds. So you can see a major speed up with DAOS over Apache Pass versus HDFS. The second application that we will run is IOR, which is a very well-known I/O benchmark in the HPC community. So we will run IOR, as we said, with two use cases, one with a small transfer size, a 256-byte transfer size, and one with a large 1 megabyte transfer size. And we will show on the right-hand side the space utilization on the storage devices, both the persistent memory and the SSDs. So the first run, we will start with the small transfer size and look at the IOPS and the latency that we get, and look at how the space on the devices are utilized. So as we can see that the IOR1 has started on the right-hand side. On the left-hand side, we can see the performance that we get in terms of IOPS. You can see that for write, we get very close to 500,000 IOPS, and for read, we get more than 1 million IOPS. The latency for write is close to 70 microseconds, and for read it is around 25 microseconds. And you can see on the right hand side the utilization of the Apache pass or the persistent memory increases as we write more data from IOR. And after the IOR1 completes, we are going to trigger the aggregation phase where we will move this data, we will aggregate this data in the persistent memory tier and move it to the NVMe SSD tier. So we'll wait till the run completes, which is, we are running IOR with several iterations, so you can see at least the performance is sustained through all these iterations. And now that the run has completed, we are going to see how and aggregation has been triggered. We will see how the space utilization in the Apache pass tier decreases as the space in the NVMe SSD increases. The second run, as we mentioned, is going to be with a large transfer size, a 1 megabyte transfer size. In this case, only metadata, the DAOS metadata, is stored in the persistent memory tier, while the raw data is actually in the SSD tier. You can see on the top left-hand side, the bandwidth that we obtained is actually the raw bandwidth of the actual SSD, which is close to 3 gigabytes per second for both read and write. And you can see the space utilization on the NVMe SSD has increased significantly with the large amount of data that has been written. This concludes our demonstration for today. Thanks a lot for listening in. Just a reminder that DAOS is open source and available for download from GitHub. Thanks again.